Today I'm going to talk about LeetCode question number 141, linked list cycle. So given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tails next pointer. That tails next pointer is connected to. That position is not passed as a parameter. Okay. Return true if this cycle, otherwise return false. Okay. So we see there's a cycle here. Okay, because we can, as we traverse through the list, we can reach this 2 again by following this pointer. Okay. Similarly here, as we traverse the list, we can reach 1 again by following this 2's next pointer. And over here, there is no linked list cycle because if we traverse through the list, we can only visit 1 once. Okay. So how do we go about this? Well, one way is we can have a dictionary or a set wherever there's over one lookup, and as we traverse through the linked list, we add each node to this dictionary. Okay. So so for example, 3, okay, we store that node, the actual object 3, 2, etc. We add 0, -4, and then when we follow -4's next pointer, okay, we find that we already have 2 in this dictionary. So in this case, there's a cycle, and we return true. How do we know if there's not a cycle? Well, if we eventually reach the end of the list, then that means there's no cycle. Okay, so this is O of n runtime and also O of n space. O of n runtime, O of n space. But there's a better way where we can use O of 1 space. Okay, and that is using the tortoise and hare method. Okay. So basically what this is we have 2 pointers, a hare and a tortoise, and the hare goes faster than the tortoise, twice the speed actually. So hare and pointer, initially if they're both at the same start ahead, hare will jump 2 nodes, while turtle will only go 1 node at a time. And eventually, if there's a cycle, tortoise and hare pointer will meet at the same node. At the same node that's not head, I should clarify, okay? And if there isn't a cycle, hare should eventually reach the end of the list. And we know reach the end of the list if hare dot next is none, or hare itself is none. Okay, so let's see this tortoise and hare method in this cycle here. So hare jumps 2 points forward, 1, 2. Okay, tortoise is 1 forward, just 1. Hare jumps 2, 1, 2. Okay, tortoise is 1. Okay, hare jumps 2, 1, 2. Hare's here again. Tortoise jumps 1. And we found tortoise and hare meet at a node. That means there's a cycle. Okay? And yeah, that's how we're going to go about it in O of 1 space. And it's still going to be O of n runtime. Okay, there's a proof on why this works. I can let you look that up yourself. But yeah, and generally this is how we're going to go about it. Okay, to code this up, so I'm going to have my hare pointer here. It's actually going to be at head, and turtle, that's going to be a head. So while hare is not none, or hare dot next is not none. Okay. We do here dot next here because just in case, like if the linked list is even, or sorry, of odd length, like hair is here, then it jumps 2 steps forward, hair is here. If we try to jump 2 steps forward from this, we get an error saying end of list dot next has no next value. Okay, so that's why we want to check if hair dot next is also not none. So what we're going to do here is hair equals hair dot next and tortoise is going to be equal to named it turtle. Tortoise is equal to tortoise dot next. So this jumps 2 spaces at a time, this jumps 1 space at a time. And if they meet, if hair is equal to tortoise, then return true. Otherwise, if we exit out of this while loop here, that means we've reached the end of the list. No cycle exists, so we return false. Okay, let's do a dry run. Okay, let's use the examples here. It should be and. Because if just one of these conditions is false, then we exit out of the while loop. Okay, looks good. Now let's try submitting. Alright, perfect. Thanks for watching.